welcome back, everyone. Hope you liked the first presentation. Remember, this is the first time that we've ever done this, and we owe a great big thank you to Microsoft for setting this up for us. This is really the first time they've ever done it.
Hold on a second. Come on. Better.
There's the technical one, going off some audio. So we're going to go with our second one now. Hopefully the audio will be better. The second presentation now is going to be on drivetrains, and we've got a lot of products to show you, so hopefully you'll enjoy it. Here we go with KING Tec.
All right, so this is the drivetrain presentation part of the Manipulator lecture, and we're going to just talk about the basics of how we can help you get going with your drivetrain. So I'm Luke Joker, I'm the captain of KING Tec.
I'm Mark Joker. I'm Mark Joker, head of electrical.
I'm Paul Hines, I'm head of mechanical.
All right. All right, so what the purpose of this presentation is that we're going to help you know what drivetrain might be the best for you guys to pick for your individual teams. What types of wheels you want. There's tons of different types of wheels. Some general mechanics of how you want to put your drivetrain together. And then in general, how to maintain it so that your drivetrain isn't going to break down in the middle of the match. So the main purpose of a drivetrain is to get your robot where it needs to be on the field and when it needs to be there. You have to be able to have a robust and reliable drivetrain. So you don't want it to break down halfway through a match or not work for 2 matches in a row, because that doesn't look great for you. And also, you want to make sure, though, that you build it so that it fits the strategy that you've selected for your robot. And then you also want to make sure that you don't go outside of your resources as a team. Also, you need to make sure that the drivetrain that you make rarely needs maintenance, but when it does, that it's very quick and easy to fix.
So imagine you're down on the competition floor and, well, your robot breaks and you can't get it what needs to be fixed, and you're kind of dead in the water. Or if you can get at it, but it's, you know, a 20-minute fix and you've only got 3 or 5 minutes until the next match, once again, you're kind of in a tight position.
Yeah, in elimination matches, you normally have 2 minutes between matches. However, and even if you take a timeout, you only have 5.
Okay, so first we're going to start off talking about the types of wheels that are mainly used in FRC. So first are traction wheels. And traction wheels are wheels that give you a lot of grip on the floor. They're very good for most drivetrains. They can't be pushed very well. So the top 2 you see here are very good wheels. They're basically a wheel with a separate tread piece, and there's different types of treads you can use. And when the tread wears out, you can replace it. They're very good wheels. There's also the Anti-Mark kit of parts wheel that has come in kit of parts in previous years. That's used by a lot of teams. The tread on that one, however, cannot be replaced, and you have to replace it with a whole new wheel. And then there's also a pneumatic tire that you can use, that's air-filled.
And KING Tec typically prefers a defensive robot, so almost every time we've used the Anti-Mark flashing wheel.
Or at least a robot that can't be pushed around.
So next are holonomic type wheels, and what holonomic or omnidirectional motion is that's where, with normal drive or tank drive, as we will talk about, you can only move your robot in one direction without changing the orientation of your robot. With holonomic motion, your robot can move in any direction without changing the direction that it's facing. So first I'm going to talk about mecanum and omni wheels. They're very similar, and as you can see here, omni wheels are wheels with tiny, smaller, free spinning wheels that are set 90 degrees to the main wheel piece. And with these wheels, it allows your robot to have a lot of maneuverability because it can turn easily, but it also can be pushed by other robots very easily. And whenever you use omni wheels, you want to always set them up in a dualies type style, which is like this, where you have 2 omni wheels set next to each other, so that where the gap is between the free spinning wheels and one omni wheel, you have a free spinning wheel of another, and that reduces the jitteriness of your drivetrain. Then there's also mecanum wheels, and mecanum wheels are very similar to omni wheels, but the little free spinning wheels are set at an angle that's not 90 degrees to the wheel, and these are, I'll give you the chance to use holonomic motion. Then there's also a crab module, and a crab module can use traction wheels to give your robot holonomic motion. As you can see here, we'll talk about this later. So the first type of drivetrain we're going to talk about is very simple. If you can see here on the PowerPoint, this big rectangle represents the frame of the robot. The small ones are the wheels of the robot. So essentially with this one, you use 2 motors and you power 2 wheels. And the other 2 wheels can either be caster wheels, Omni wheels, or some sort of smooth plastic or something. And with the powered wheels, you want to make sure that you use traction wheels. Otherwise, your robot won't perform very well. It's a very simple design here, very easy to build, very lightweight. It's very inexpensive. It's fairly agile, but like I said, it's not very powerful, and it doesn't do well on ramps, and it can be pushed very easily by other robots. So this robot is one step up from the last one. Essentially now, instead of only having 2 wheels being powered, you have chain connecting the powered, what used to be the only powered wheels, to now new powered wheels. So you have all 4 wheels being powered. And with this design, you can either use all traction wheels, all Omni wheels, or a combination of both. But if you do use any amount of Omni wheels, that will make it easier for other teams to push your robots. You have to be careful about that. If you do use traction wheels, though, all traction wheels, it's very difficult to turn with this setup. It's not agile at all, but it's much more powerful than the last drivetrain. It's still easy to build, really inexpensive, and fairly lightweight. So this is another step up. So now instead of using 2 motors, you're using 4 motors. So you still have all 4 wheels being powered. This is the only setup you can use for Mecanum drive. So you want to note that. We've seen teams in the past that have used the wrong setup for Mecanum drive. So you can use traction wheels, Omni wheels, or Mecanum wheels with this setup. And like I said before, if you use Omni wheels or Mecanum wheels, your robot will be easier to be pushed by other teams. It's a lot heavier design than the earliest ones we talked about. Mecanum wheels can get very heavy and they're very expensive, so you want to think about that before you decide what you're going to build. It's, like I said, it's hot, heavy, costly, very powerful. Yeah. This is a really good drivetrain in FRC. It's a 6-wheel drive, and you can either have all the wheels at the same level, or you can have the center 2 wheels here dropped 1/8 to 1/4 of an inch. And what that allows you to do is that makes it so your robot is only sitting on 4 wheels at a time, which gives you a very small turning base, yet you still have the other 2 wheels to rock on. So you have that wide frame. This is a very strong drivetrain. It's very powerful. It's very agile because you have the small turning base, but you still have the wide frame. Very agile. It's fairly easy to build. We're getting a lot heavier now because we're using more and more stuff, but it's still very easy for new teams to build. This is a tank drive, and where the last drivetrains used wheels, this is pretty much the only drivetrain that uses treads. And so you essentially have some gripping material, kind of like the material that was used on some of the wheels. Now you have a huge tread made out of that. You have to be careful with the treads because they can break, which can become a problem. It's a little bit more complex drivetrain because you have to build your robot so that the treads don't walk off the wheels that are powering them. It's a very powerful drivetrain. It's somewhat agile. It's expensive. This drivetrain is very good for going over things. That's its sole benefit.
It's important to note that if this does not actually push any better than a 6-wheel drive would, it just has more surface area so that it's less frequently not in contact with the floor, or it doesn't actually get any more pushing power.
Same as the bed of nails concept.
Yeah, similar to.
So tank versus holonomic motion. I described it a little bit earlier, but basically tank drive is what all of the drivetrains we've talked about so far uses. It's where the robot can only move in one direction without changing the orientation of the robot. Versus holonomic motion is where you can your robot can move in any direction without changing the orientation of the robot. So this is the first type of holonomic drivetrain we're going to talk about. It's called Killough drive. You can either use a 4-wheel setup like above, or a 3-wheel setup such as below. And with this drivetrain, you use Omni wheels. And
So is mine.
And you put them at angles to the frame so that they're tilted inward slightly. This drivetrain is very good for turning. It's very agile. It has harmonic motion, like I said. But it can be pushed very easily by other teams because you're using Omni wheels. It's very simple to control versus some of the ones we're going to talk about next are a little bit more difficult to control. It's getting heavier, more expensive, a little bit more complex to program and build and somewhat, not what. But, yeah.
All right, this next type of drivetrain is called a mechanic drive. And the way that it works is you have a 4 wheels that are independently driven, and each one of the wheels has to be a mechanical wheel. And then the benefits of that are that it does allow you to have the harmonic strafing ability, and you can actually have any combination of moving forward, moving laterally, strafing, and spinning at the same time. And so that's pretty much the only benefit of the mechanic drivetrain. There are several issues with this where you won't be able to push as well, and it'll be a lot easier for other teams to push it during you. So in general, you probably want to stay away from this. And then there are also other issues with it, such as you generally want to have suspension on the wheels, because otherwise, if you don't have an even amount of force on each of the wheels, those inverse kinematics that you have for the programming for it are just going to go out of the window. And instead of strafing, if you hit a bump, like if you use a plywood under the floor, which they have had in previous years, then instead of strafing, you're suddenly going to be spinning, and drivers usually don't like that too much. So my personal favorite kind of harmonic drivetrain is called a crab or swerve drive. And the way that it works is the individual wheel modules actually will rotate. Actually rotate, as you can see here, so that the robot can move in a different direction. And the benefits of this is that you can use high traction wheels with this versus with a Mecanum or a Killough setup. And so that allows you to maintain all of your pushing power and still have harmonic motion. So some disadvantages of this are that it is a complicated system to make. As you can see, there's a lot of chain and different gearing and stuff here. Yes, you have to have some method of changing the power to the wheels from a gearbox, or just mount the motors here, but that can then it can get in the way. So some other disadvantages of this is that it can be difficult to program. If you don't already have that kind of programming in the bag before the season starts, then I would be very hesitant to start during the season.
It's also important to note that, as you can see right here, there's a potentiometer hooked up to the main orientation system of the drivetrain, because the drivers on the field can't really see which direction these wheels are oriented, especially if the robot is 50 feet away on the other side of the field.
Especially with bumpers.
So this potentiometer can tell which direction the wheels are oriented, so the program can account for that. And so this way, when the driver presses forward, the robot actually goes where he or she expects it to go.
Instead of just going in some random direction. Drivers also don't like that very much. I know, they're just so picky. So one thing to note with drivetrains is what speed you pick. And this is going to be entirely dependent on the size of wheels that you choose, and also the gear ratio between your motors and the wheels. And the reason why you want some kind of gearing is because the motors that you're probably going to want for your drivetrain are these sim motors, and they're spinning at about 5,000 RPM with not a whole lot of torque. And so if you just hook one of those up to one of your wheels, that's not going to work too great. And we have seen people do that. So what you want is have some form of a gearbox. Like this is the one that was provided in the kit last year. It was called the Simple Box. It's about a 5-to-1 reduction. And what that does is it does slow it down, but it also gives you significantly more torque. So some good speeds to aim for are, if you're looking to be a purely offensive robot, a controllable top speed is about 15 to 20 feet per second. Usually don't push 20 too much, because then you'll have difficulties with acceleration. If you're looking for just a average speed so you can push a bit and play offense a decent amount, then about 10 feet per second is a good landmark. But then if you're looking for just a purely defensive robot, 5 feet per second is about where you're going to have your best success. This was created by Team 1114, a very good team from Canada, and essentially the way that it works, it's a weighted comparison table, and what you do is you select the values that are for your own individual team, and this will kind of give you an idea of what drivetrains might be a good choice for your team. So this will be up on our website later, also on the Minnesota First website, so if you want to look at it more in depth. So we also include some weights that some newer teams might choose to use. And once again, this will be up on our website later. So some of the gearboxes and stuff that are kind of already covered with is that another one of the benefits of having a gearbox is that it'll decrease the amount of load on the motor. Because if you just had this hooked directly up to the wheel, you're going to be drawing a lot of current, and you're probably going to blow some relays. And drivers also don't like that because then they're all stops moving. And then another thing to remember with gearboxes is you want to keep them greased, so that otherwise, if you don't have them greased, you're going to be wearing down the gears pretty fast. And then also the greasing will improve the efficiency of your gear adoption.
Another thing that's really good about gearboxes, if you're a little bit more experienced team, on AndyMark.com there is available 2-speed gearboxes that can shift between a low gear and a high gear. And that's really good for competition because you can have low gear for when you want to play defense and high gear for when you want to zip across the field, such as last year.
Exactly.
So we're going to talk about chain right now. So chain is used for almost a lot of applications on the robot. So we're going to talk about the 2 different types of chain that are mainly used in FRC. So we have 25 chain right here, this smaller chain, and 35, this larger chain. So with 25 chain, it's a lot smaller, as you can see. It's a lot more lightweight. You kind of want to try and go for 25 chain if you can. It can be used for most applications on your robot, and it's a lot lighter than the 35 chain. 25 chain, it's a lot more lightweight, like I said, it's smaller, it's easier to install. And with chain, you're going to find that all chain will stretch over time. It will essentially stretch. It's really just wearing down, but it's stretching. So with 25 chain, since there's a lot more length, it'll stretch more than 35 chain, which is one good thing about 35 chain. But again, 35 chain is heavier. And 35 chain will also allow for a little bit more slop, since there isn't as many teeth in the sprockets, so it has less chance of skipping out. So another thing with chain is you want to make sure that you have chain brakes. And chain brakes take out the pins in the chain so you can adjust the length of the chain. So this is a dark sole. It can only be used with 25 chain, but it's a really nice thing to have for your team. It can both take out the pins in the chain and put the pins back in, whereas 35 chain, you can't do this, and you have to use something called a master link. And that's essentially a little clip that clips the pins together, and it's a lot more annoying to work with. So this is a chain brake for 35 chain, for example. And then this is a chain puller that's kind of useful to have, and it pulls the 2 ends of a chain together when you kind of have it a tight fit, So it helps pull them together so you can assemble the chain more easily. Like I talked about, you want to have, I haven't talked about this yet, but you want to have a tensioner on your robot for almost all your chains. Because like I said, it's going to stretch over time, it's guaranteed. So you must have some sort of tensioner on your robot. And this tensioner must be very accessible on your robot because you won't sometimes have a lot of time to tension it when it needs to be tensioned. And I already talked about chain brakes. Make sure you try and get a dark sole if you can. It's very useful to have.
All right, so now that you guys at least an idea of what a drivetrain looks like, we'll talk about powering. So the core of your power system is this, the power distribution board. It's going to hook up to your battery here, and then it's got lines going out to whatever you might have to need to power. However, when you're playing electrical board, this is one of the biggest things on there, so you're going to want to put it rather centrally, because not only is it very hard to fit, you need everything to need access to it, from your motors to basically anything you're going to put on the sensors or where it happens to be.
Everything needs power.
And when you place it, you also want to make sure you can get easy access to it. Like we talked about before, if you can, if you need to repair something and you can't get at it, you're kind of in a tough spot. If it's hard to access, it's also a lot easier to accidentally cross wires and short something out. As you can see along the top here, it also has a position for breakers, so you can put 40 amp, 20 amp, 30 amp breakers in there, depending on what power application you might need. Most sims are going to run off 40, but smaller stuff will run off 20 or 30. These breakers are very essential because if you've got like shorts, without these, well, something's probably going to light on fire, or burst tends to frown upon fires.
Just a little bit.
So they do happen, we try to avoid them as much as possible. The other important feature part with this is what wire you're using. Wire is rated by gauge, where a higher number means a smaller wire, and a lower number means thicker wire. And the advantages of smaller wire are that you can bend it more easily and you can get it into tighter position. However, it doesn't transfer as much electricity, so something like your battery, especially, isn't going to run off of 16 gauge wire. That's going to be more like 8. Right, and then in between your power distribution board and the motors are going to be these, what you call motor controllers. The two models that first accept are Jaguars and Victors. We'll start with the Victor. It obviously has a much smaller footprint, making it a lot easier to position. And it can also handle high amperage a bit better. The Jaguar contains a safeguard that prevents it from, or that protects it from high amperage. However, when you're running something like your drivetrain, to get up to full speed, that high amperage is necessary. What's notable about Victor is it also has a separate fan module that you need to install. However, it's maybe 2 minutes of extra work, not that big of a deal. The Jaguar has slightly smoother controls, which makes it slightly easier to program. However, the Victor is no challenge. And the Jaguar is also an enclosed system, meaning that you can protecting it from shrapnel or anything else. So it's by no means foolproof. Let me just say, whenever you're working with anything on your robot and you've got your electrical systems there, please cover with a plastic bag or something to keep it safe. Just a single piece of shrapnel from drilling can short out one of these wires and can cause it to light on fire. That's, again, just something we try to avoid. And like I talked about, the Jaguar does have the issue of high current. So, typically, the Victor's going to work best for your drivetrain, and then Jaguar will work fine for things like claws and arms. So it's up to you to decide what feels best for you.
So thanks for everyone for listening. Just a quick note for some people of where we got some of the stuff for the presentation from. A lot of the wheels and such we got from Andy Mark. 221 has some of the nice pictures, and then 1114 had that very nice way with the projective table. And once again, this will be available on our website and the First Minnesota website afterwards, so feel free to take a look at it again. Thanks for listening.
So we got a comment from the audience that they'd like to see the robot up close against
Yeah,
the
definitely.
air. So,
Which one would you like to see?
yeah, show all the different parts and pieces.
Great. So this one is the swerve drive, and as you can see, these motors are the ones that actually power the rotation of the wheels. However, this motor here, where did it go?
Down there.
Yes, this motor here is the one that powers the rotation of the wheels. As you can see, all of the wheels rotate together and have a lot of torque because we need it for that here.
So essentially, with a crab drive or a swerve drive, you're going to have one or more motors that drive the wheels and make your robot move, and then you're also going to have one or more motors that make the wheels rotate.
Tip it up again, guys. Other way. Other way. The other thing that I want you to notice is this module right here. There's one chain that will drive the orientation of the robot right to left. The other one actually spins a spindle which goes down to a 90-degree gearbox, which we can rotate this. Other way. 90-degree gearbox here, so it can transfer then the energy back into the axle. So that's why we have so many chains up on top here. But if you're going to work with this type of system, you have to have a chain that either drives 2 of the wheels or 4 of the wheels at the same time, and then a system that takes it from your power into the axle shaft, which drives the wheel itself. So it's relatively complicated, but when you understand it, you can put it together. One last thing to note is this right here is a little idler gear. And what it does is it takes up the slack in the chain, and we have a little tensioning device here where we could loosen it to be able to get it in and then push it back to get it to tighten up. So you want to have that because you don't want to have any slop in this chain. And if you are going to work with number 25 chain, remember that you have to keep it in alignment or it will skip out on you. 35 chain is very forgiving, 25 chain is not. We like 25 chain because it's very lightweight, but if we're doing anything heavy duty, like you can see on these drive wheels here, they have 35 chain, or our arm last year we used 35 chain. So,
Alright, then for this one here, this one is that 2-motor drivetrain that we showed earlier in the presentation. So the way that it works is, so it's not completely put together, but these motors power these back wheel traction wheels, and then these omni wheels in front, these are just like these smaller ones that are just bigger. So they have the rollers that are free spinning, and so these wheels are also free spinning, and they essentially act as casters.
And then I talked about chain tensioners. This is an example of a tensioner we made. It's essentially just a piece of aluminum with springs attached to it and a sprocket on it that moves freely. So the springs just pull the chain up and it keeps it tensioned.
one of the things to note on this is if you take a look at where we put the battery box, we actually dropped it down. And the reason we did that is to have a lower center of gravity. And I'm going to give a tip to all of the teams that I just found this morning. If you go on to the first website for First Choice, you will see the optional material that you can order. And one of the things that you'll be able to order from Andy Mark this year is a drop wheel system which elevates your chassis. Bring that over here again, please. And that's what these are here. They're available on First Choice again this year. That might give you guys a hint as to what the game might be this year. We're trying to figure that out with KING Tec right now. The other thing about that you have to remember is that if I have my chassis up here, now I'm raising my center of gravity, and you're going to have a greater chance for it to tip over. I'd like you guys to put this on the table once and demonstrate how chattery those wheels are.
The way to get around having wheels this chattery is by taking an individual one of these wheels and pairing it with the second one in a dually setup so that the rollers are offset so that you always have one of the rollers contacting the surface. And that removes the jitter that you would otherwise have.
Any questions on that?
People were asking about where to get aluminum, drop wheel systems.
The easiest place to get aluminum is probably just a local hardware store or some other vendors in the area.
There is also a McMaster car, which is a really good website to buy metal or pretty much anything you need for your robot. They probably have it at McMaster car.
Yep.
Handymark is a good place for parts for your robot, not metal, but parts such as these, I believe, are on handymark.com.
And then also in the past, in the kit of parts, they actually will generally come with a drivetrain that's pretty much just ready for you to put together. And that might not be the one that you end up going with, but it's definitely a viable option.
MasterCard is very good, but if you're local around the Twin Cities area here, Discount Steel is probably your best place to go. There's several teams that go there. They have some really great product, but if you have to order it in, McMaster is probably your best place. But for all of you teams out there, I'd recommend that you try to establish some relationships with your local vendors within their community. See if they'll support your team. You'll be amazed at how much product that they will give you. Also, look for a manufacturer around your area, because many times they'll donate their scrap parts to you.
There was a question about batteries. You are given a battery in your kit of parts, and you must use that battery. You can order extra batteries, but it has to be the exact same part number. So you're not allowed to go out and find your own 12-volt battery. So that's one of the things they do to level the playing field so that everybody has an equal advantage.
Yeah, because otherwise you just have a massive battery that can put out as many amps as you want, and that wouldn't be fair to someone who just doesn't have resources.
Mark, how many batteries do we have in our pit area that we charge at any given time?
At least 5.
At least. We're probably going to have 7 to 9 batteries this year. We're going to buy more. Another tip for all of you teams out there, Andy Mark just came out with a new product. It's a charger that will allow you to charge 3 batteries at a time. I recommend that many of you teams try to look for that and get it, because if you are driving on the field and you only have 1 battery as backup, and if one of those batteries goes out, you're going to be in a world of hurt. So you want a lot of batteries there, and you want to make sure you can keep them fully charged if at all possible.
And they actually are terribly specific on what type of battery they let you use. We were at a competition last year, and I remember seeing a battery that looked identical, but it was colored black. And technically, that was a separate part number. There was no guarantee. There was no way of guaranteeing that that was the same battery, so that battery was not allowed to be used.
All right, another question was once again, how this works. So the way that works is, so here's the motors, and then here's the gearbox, and then the chain powers these back wheels. So you can drive using those, and this one also is driven by this gearbox. And then these front Omni wheels essentially just act as casters. They're free spinning, and then these rollers let them have minimal coefficient friction in the transverse direction.
This one has rollers here, which go in an exact opposite axis to the axle, so it allows it to slide on the front. If you have a really long axle and try to turn, you'll shatter the front of it. The other thing to note here, there's 2 transmissions on here that are both used extensively throughout FIRST. This one here is from Bainbach, and this one here is from Andy Mark. For us, for the drivetrain, we like Andy Mark almost exclusively. We've had several issues with Bainbach. However, for things like arm mechanisms and so on, these Bainbach transmissions can work fairly well with that, but I would not put them on a drivetrain. At least we would not for KING Tec. But you'll see these quite a bit through many of the teams with FIRST.
Any other questions?
Do you guys have questions and we haven't answered them yet? Please unmute yourself and ask a question.
Anybody from the audience here? Okay, Nathan had a really good plug. The Dark Soul, we're not getting any royalties off of this, even though we have plugged it. To use this with the number 10 chain, you cannot, or 25 chain, you cannot stress that enough. We have had problems with the 25 chain with the kingpin coming off, and we've heard of team after team having the same problem. We actually had one robot where we had taken it and soldered the kingpin on. When you use the Dark Soul, there is no kingpin. You actually pull the pin of the chain itself out, and you push that pin back in and knurl the end of it, and this little tool does all of that for you. So if you are going to use this chain to save some weight, which we recommend, make sure you try to get a tool like this. Dark Soul is the one that we found works best, but there are other ways that you can do it too.
Question from John, from Mora, from start to finish, how much does that robot pay to build?
Which one? The swerve drive or the...
It is specify which.
Talk about both.
All right, well, this one we put together in a few days.
I'd say it's less than that.
Yeah, it took us about a day to make. This is a very simple drivetrain. All you have to do is throw these wheel brackets in, drop an axle in with a wheel on each of them, and then just throw the chain in there, and it is good to go.
And with any drivetrain, you want to make sure that you start off building the chassis first and then build onto the chassis. The chassis is what you build off of.
And then with the swerve drive here, that's the one that we used in the 2009 competition Lunacy. And this one did take us a bit longer, what we say about.
It took us 6 weeks to build that robot.
Exactly, 6 weeks to build this. And the reason for that was that we had never built a swerve drive before, and so it took us that entire time to just figure out how to do it.
And we had a mechanism on top of this robot that would actually suck in balls off of the floor and pull off an elevator platform to allow them to shoot. So it sounds like somebody's here to ask a question. Is on the mic or not?
Somebody just joined by phone, 218-640-6010. You have a question?
Oh, okay. Good. Nothing more from the audience here? Okay, well, thank you for participating. We appreciate it. The next presentation we're doing is on mechanisms, which I think you'll enjoy quite a bit. So we're going to take about a 3 to 5 minute break here just to reset, and hopefully we'll see you all back. It's going to be a really good presentation. Really stick around for it. Thanks.
Somebody asked a quick question. Can we keep the schedule? The next one starts at 7:15.
What we did is we actually had pushed 3 presentations into 2 slots to give you guys as much information as we can. So we're trying to